Hello, everyone. In this session, we'll look at large language models in context with retrieval augmented generation or the RAG applications. So my name is Magino Daniel, and let's dive in. So we shall start with a brief introduction. Large language models are specifically probabilistic models of text. That means they generate their text depending on probabilities, or they base on probabilities to generate their text. So the large in large language models or the term large in LLMs means the number of parameters with no threshold agreed upon. So that means it has no limit of parameters you can use in that model or you can use to train the model. So a brief way how it works is when you prompt a question, let's say I wrote to the zoo to send me a pet, they send me a so what the model is going to do, it's going to check in its vocabulary and assign probabilities to what can be suited to be a pet. Are you getting? So we are looking at the dog having a higher percentage of or probability of 0.3 and the cat is having 0.2. So this implies that most cases dogs people like having them as pets. So that's why it's having a 0.3 and the cat is having 0.2. And then you're going to find that the alligator, the panther, they are having lower percentages or probabilities. This is because these are not regarded as pets, they are wild animals. So majorly that is it. And for encoders and decoders, we need to understand them too, as they also play a big role in large language models. So encoders are majorly designed to embed text or convert words into an embedding. That's to say vector representation. So we have an example that is mini LMS BAT, the BAT model, the Robata model. So sorry, architectures. And then this diagram here is representing a BAT style model, how it works. So, for example, that same question, so that same sentence we used, they sent me a, assuming it is broken down and sent to the model. I see all these are sent to the model. Then what the encoder model is going to do, it is going to embed each of them. Are you getting? So not convert them into embeddings. And these are the results of the embedding. So each word has got an embedding. They sent me a. Then this other extra, the fifth, is majorly for the whole sentence. It represents the whole sentence. So primarily it uses embeddings, tokens, sentences, and documents. So majorly that. And then for the decoder model, it takes a sequence of words and outputs the next word. For example, we have GPT-4, Lima, the Bloom, the Falcon. Then still using the same sentence, they sent me a. So what happens here? This decoder here only produces single tokens at a time. Are you getting? So that means it feeds in a sequence of these sentences. And then later on, they will be invoked to produce the next token. Are you getting? So that's in summary about the two encoders and the decoder. So encoders majorly they focus on embedding text, whereas for the decoders, they focus on text generation. So let's look at the encoder decoder. So this one has got both the encoder and the decoder. So what happens? The encoder decoder encodes a sequence of words. Are you getting? And uses the encoding to output a new word. You're getting that? So we are still going to use the same word we used. They sent me a. We remember this was our encoder and this is going to be our decoder. So the encoder is going to convert this into it's going to convert it into embeddings, which are vector representations. And then later on, these will be fed into or passed into the decoder that's going to decode these words one at a time. You're getting? It's going to decode them one at a time. So what happens here, it's more of a self-referential loop. Are you getting? That's made to decode, generate tokens one at a time. So the token is then passed back to the next token word. You're getting? So majorly, this is what happens here. And then we have the RAG itself, the Retrieval Augmented Generation. So with the RAG, it enhances LLMs. It was brought in to enhance LLMs by retrieving relevant document chunks from external knowledge base. These documents could be PDFs, Word, HTML documents. So the relevant documents and chunks from external knowledge base. Getting from could be databases and all that through semantic similarity calculation. Now, semantic similarity calculation is more of an algorithm that calculates the similarity of two words. If there's a higher score, then these words really mean the same or are similar to each other. Getting so by referencing external knowledge, the RAG effectively reduces problems such as hallucination. So hallucination, this is we're looking at the model generating responses basing on patterns rather than understanding that query or the prompt that was given to it. Then we have knowledge gaps. You find that majority of the models are trained on limited data or no data at all. Again, so you may find that in that domain, there is no, or the data you need to retrieve is not enough. I get it. So then we have the outdated information whereby you find like some models are trained on data for some time and they may not have what is current at the moment. They may have, maybe let's say it is trained on data up to 2021 and right now in 2024, it may not have. I get it. Or in the other previous, or in the other current years to come, it may not have the other data. That's why we need the retrieval augmented generation. So the processes involved in the retrieval generation applications or systems. So we have the first one, that is indexing. So what happens here, documents are split into chunks, they are encoded into vector representations, and then later on they are stored in vector databases. You getting? Then for the retrieval, what happens, it retrieves the top, let's give an example, the top K chunks. I getting, can give them a name K, the top K chunks that are most relevant to that question that was prompted or that query that was given in, and that question that was based on the semantic similarity algorithm that checked for the similarity. You getting? Then we have the third one, that is the generation. Now what happens here, what happens here is you input the original question and retrieved chunks, the ones that we got, the similarities we got, the retrieved chunks together into the large language model so that it can generate the final response or answer. You're getting? So sometimes we may want to also understand what augmentation is. So augmentation is simply refers to the process of enriching. Uh, enriching could be enhancing the input data by retrieving relevant information from the external sources. That could be, for example, the base, the knowledge base, documents, or databases, and all that. You're getting? So majorly that is that. And for this, we have a representative instance of the RAG process applied to the question answering. You're getting? So what happens here is a user that was in the older manner or in the older way when GPT used to work without the RAG application, a user would prompt in a query, and it would, if that query is not of that, if it was that query that was prompted does not have any data of current, or the model does not have the current data, the model normally would respond back, without that information. I don't have that current information for now. I don't have it based on the parameters I was trained on, such kind of responses. You're getting? So when these are, so when the RAG applications were brought in, the retrieval augmented generation was brought in, it made some changes. So what happens is the these stages were introduced: the indexing, the retrieval where we have the relevant documents, and then we have also the generation. These were brought into place. You're getting. So what happens is when a user puts in a query, we have the indexing stage here that extracts and gets documents. It gets documents, could be PDFs, Microsoft Word, and all that. It retrieves these documents, cleans them, extracts information out of them, and then break them into chunks. You're getting. After doing this, these documents are an embedding model is then brought into place to convert these documents into vector representations. Then later on, they are stored in the database. I getting. So then the retrieval part comes in where it's going to retrieve the top K chunks that are most related to the question based on semantic similarity. You're getting. So that is now for the retrieval stage. This is what happens in the retrieval stage. But now in the retrieval stage, remember, for this to happen, for the semantic similarity to get this, that means a copy of that prompt is given to the retrieval stage of that query that the user put in. And then that same query is again passed into the same encoding model to convert it into vector. That is a vector embeddings. Then later on, check for the similarities with the chunks that are in the vector database. Are you getting? So when it gets the top K, the similar ones that are similar to that response, when it gets those similar ones, then it's going to put them in a context as a prompt. So then later on, the generation will come in and accept that prompt from this retrieval, accepts the prompt together with data input for the question. Then the model in the generation combines the two and then provides a better response or feedback you're getting. So that means they are then later on passed into the LLM to generate a better response to the user. So majorly that is it. That's the prompt that is here. And then this is still the same kind of explanation, though this is the same kind of working of a RAG application, but though in a different way. That is with modalities. As you can see nowadays, ChatGPT has got these modalities also. So the modalities are more of like, let me say, shortcuts you're going to have to get a certain response. Maybe you want text, you want code, you want image, audio, and all that. You're getting. So they're just like, let me say, menus you tap to get feedback, could be answers, or and all that. So these are input into the retriever, then the generator. Here they are both entered in as input. So what the retriever is going to do is going to carry on the indexing that we saw already. The indexing where the RAG application or the model retrieves documents, breaks them into small chunks, and then later on converts them into embeddings and stored in the database. I get it. So then the retriever comes into play. The retriever comes into play to get the top K, to get this top K similar. There could be similar text that is similar to that prompt that was brought in or that was provided in by the users. I get it. So that to get the other answers that are exactly the explanation to what the user wanted. So then later on, this retriever, after getting that, it's going to be taken in as a context and prompt into the generator. So the generator is going to bring in that input, is going to bring in that context here or that prompt, the context here together with this input prompt here. They're going to bring them together. They're going to be passed to these models depending on what the user wants. Could be Hugging Face, which is for image detection and all that. Could be OpenAI. Maybe you want it to generate text and all that, diffusion and GAN and all that. So then later on, this model after passing the input and context into the model, it's going to generate a better response to provide to the user, which is this as the result. Getting. So that is it majorly. Then we have lastly this. This is an architecture we are working on for our project, and still it portrays the same things I have just explained. It portrays the exact same things. So still here, a user is going to enter a prompt into, could be an application now. This time it's an interface you have with you. And then remember, this represent the security measures you have to secure from the user's end, the prompt, and even the during the usage of the application itself. So the prompt is entered, later on taken through the, could be an REST API maybe, depending on what API you're using, then to the back end. Then the prompt is sanitized here, you can see. Then taken in for embedding. So the embedding model is going to convert that prompt into vector representations and check for their similarities in the database. You're getting. But then remember here, we have this where the indexing takes place. Cleaning of the, could be the PDFs, Word, and all that. Cleaning them and extracting the information from it, breaking it into chunks, and then embedding them and storing in the vector database. So it's a similar process that will happen here with the prompt we are going to take in here. And after that, the generation, though you may not see where the retriever and generation and all that, where they are, but still that is the same steps that are taken. So here is where the retriever will come in. Sorry, this is where the generation the retriever will come in to check for the top K similar texts that are similar to that prompt that the user put in. So that's why we have the most relevant text that is passed through the context. So together we shall have that same prompt here and the context we got here that will be passed as the context and the prompt to the large language model so that it can provide a better response to the user. So the response is taken back to the back end of the application. Could be maybe you're using Python, depending on what back end you're using. Then back to the front end of the application and back to the user. So then we have these logs for security purposes to check who accessed this, who used this, and that, and all the others. Yeah. So basically, this is it for the RAG applications in context with the large language models. So in conclusion, that means without a RAG application, the model majorly relied on purely existing knowledge, which led to outdated or generic responses. You're getting. But now with a RAG introduced in it, the model enhances its capabilities by retrieving external relevant documents and combining them with its own reasoning so that the user can have a better response. So majorly that is it for the retrieval augmented generation in context with the large language models. Thank you so much.